For the last unit in special senses, we're going to first compare and contrast the general senses to the special senses. So, hopefully, in this little introduction, I can try to convince you that this is kind of the culmination of the whole semester, is the special senses. It's the last unit you did in lab. You now have the tools to understand how this works. You understand how an electrical signal is generated. You understand how do you send it somewhere. You understand what does it go to, whether it's a gland or whether it's a muscle. You understand how does the brain interpret. What centers are responsible for different types of signals. Then what do you do with that information that you gather? You send it out to a motor output, an efferent pathway, and it goes to a target tissue to actually have a response. So our sensory input is our way of interacting with our environment. It's critical to who we are. It's critical even to our intellectual function. In fact, there have been some pretty disturbing types of studies done on restricting certain sensory input during development of organisms. And the results are, a lot of people don't want to hear about. You know, like in primates where you cover one eye or both eyes, or, you know, you restrict sound or you restrict touch, okay, in a developing primate. And there are behavioral abnormalities that take place, right? There are socio-pathological problems that develop when you restrict just physical touch to a developing primate. So there is a lot of value in the way that we see our world, the way that we interact with our world, and the way that our world interacts with us along our development. Bless you. And you don't really value a lot of this input until, unfortunately, something happens and it goes away. I mean, that's you know, I'm guilty of the same thing, right? I mean, you don't really know what you have until it's gone. So if you have an accident, or there is trauma, or there is a medical condition of stroke, and you lose hearing, or vision, or sight, or touch, or motion, motor activity, then you understand the impact of how you no longer benefit from interacting with your environment. So this information is communicated from a sense organ, a structure. And a lot of times, it never comes to our attention. Like, we don't even know that it's happening. I'm talking about things that you know about, like physical touch from a caring individual, or visual cues of beautiful scenery, or olfactory sensations of, you know, baking or cooking or breakfast when you come down the stairs. Okay? Coffee in the morning, right, is like straight from heaven, isn't it? Like, oh. And some of you aren't coffee drinkers. I don't know what's wrong with you. Not enough physical touch when you're a child, maybe. But blood pressure, body temperature, and even muscle tension. A lot of these things that we are receiving input all day long, all the time, doesn't come to our conscious awareness. pH. You know, you're like, the pH is a little off. Better. Okay? Like, you don't, like, what? You just missed it. You have to watch the YouTube. There are sense organs that actually initiate somatic and visceral reflexes. And they're critical to our survival. Right? So, reflexes that tell us when it's time to urinate. Reflexes that tell us, you know, that is a hot stove and I just about burned myself on it. So these agents or these elements are absolutely critical to our survival. Right? And if you go into the literature, you can just Google, you know, primate research on restricting vision inputs or nurturing touch in a primate during developmental years. It's a little frightening that this research has been done. I get that. But it also is eye-opening to let us know how important it is. So there is that balance between research and, you know, what's allowed to be done. Okay? But take home this. Critical to how we are today. Right? You're a product of your environment. In that environment, you interact with using these receptors. Okay, so that's my little introduction to this segment that we're on. It's kind of a fun segment. Well, you're going to have a receptor. What's involved? What are the components? This is the structure that actually detects the stimulus. A lot of times it's a nerve ending. We'll talk about all sorts of different varieties. Sometimes we have a sense organ, where there's a nerve ending and then there's tissue surrounding that nerve ending, and that helps to enhance the response. Make it more sensitive, okay? Get rid of some of the noise, kind of focus in and hone it. Now, you guys have seen this structure right here. What is this? That's a Meissner's corpuscle. That might be on the practical this week, I'm just saying. Okay? Meissner's corpuscle. Might be. Right, this is a sensory organ that has a corpuscle around it that encapsulates it to make it responsible for what? What kind of touch? Light touch. Okay? So that's recognizing that, you know, you didn't forget to put your shirt on today when you walked out of the house. Or, yep, I'm wearing my pants because I can feel them versus, whoops, right? So obviously very important for us to know about light touch environment cues from our environment. Then we see other things like the properties. If we're going to look at the properties, we've got really 4 general properties. Number 1 is the receptor. This is the specialized structure that detects the stimulus. We said that they have bare nerve endings at times. Other times they're encapsulated. That encapsulation or that tissue that surrounds it can enhance its activity. Then we have to send the signal somewhere. You have to transduce the signal. You convert the energy from one form to another form. That's what one of these receptors does. Is it says, okay, I'm going to take mechanical stimulus, I'm going to convert it to an electrical signal to send it to the brain, because you can't do that and say, oh, wow, that smells good. You with me? Yeah, I'm seeing you. Okay? It's getting hot in here. You don't send a mechanical signal to the brain to interpret your outside environment. You send an electrical signal. So there has to be a conversion of the energy form. So this is fundamental to any sensory receptor. You convert it if it's light or heat or touch or sound. It has to all be turned into an electric signal, because that's what your brain interprets. Hopefully you get that, because we've covered that much of this semester. Now, the sense organ is very much like a gasoline engine or a light bulb. They're all types of transducers. What does a light bulb do? What is the transfer of energy for a light bulb? Look up. Everybody look up. See those light bulbs? Ow. So how did that register out? Where was the transfer of energy? The light bulb is emitting what kind of energy? Photons, right? Light energy. And then your, ow, that is bright. Then your eyes, and we'll get into vision, detect that light energy and does what with it? Converts it to what? An electrical signal. And sends it to where? Where? The occipital lobe, right? You guys are beyond that now. Brain. Right? You can tell me what lobe it is, I hope. All right, and how does it do this? It does this using a receptor potential. What does that word mean to you now, at this point in the semester? A receptor potential.
Potential to receive.
What does that mean? What is a potential? The energy potential, right? That is a difference in electrical signal. So these are local electric changes that's brought about by that initial stimulus. That stimulus could be mechanical, It could be electrical. It could be light. It could be heat. It could be pH. The stimulus could be a number of different things, and you're sending it via an electrical signal. There's probably the release of a neurotransmitter along the way that's going to cause numerous types of signals to go into different locations in the brain. And then lastly on this list of general properties is a sensation. So this is the awareness that something is happening. Awareness that, oh, it's light in the room. Or it's too dark, I can't see anything. You know, awareness that noise has to be filtered out in the brainstem, bless you. And just because you're not aware doesn't necessarily mean that you don't perceive the sensation. Like, for example, pH and body temperature do stimulate a sensation that's detected, but it's detected more at the autonomic level, so there's not a conscious awareness. But there's still a sensation. But many of the things that we're going to look at with the special senses are an actual subjective awareness of, yeah, that's beautiful scenery, or that smells really nice. Okay? That tastes wonderful. So let's quickly talk about the differences between general senses and special senses. When you guys see a slide like this, what do you think I'm going to say? Homework, you got it. So I want you to give me some characteristics of general senses, characteristics of special senses, and then tell me where they're located. Tonight, before Wednesday. That's kind of what homework means. You do it when you're home. Okay? All right, stay with me, guys. Give me, you guys are chatty, so talk to your neighbor, that's fine. Give me an example of a transducer. And I want each of you to come up with one. Okay? I've listed off a couple, like a gasoline engine, a light bulb. Don't give me those. Give me new ones. Something that's converting one form of energy to another. Okay? Talk amongst yourselves. I want to hear them. Let's hear some before we leave. What's that? Crank flashlights, right? Crank flash. Don't even need batteries. It's converting mechanical energy into electric energy. Okay, what else? A gas engine. Okay. What else? A water mill. What else? A wind turbine. What else? Solar panels, like what we see on this house. All right, so you have a homework assignment. That's this one. And you have an idea that you can go out in the real world and you can see transducers everywhere. This is where we're going to pick it up on Wednesday.